Welcome to IAS level physics unit 1. This is part 4 of the entire unit 1. Today we'll be looking at 17 till 22, so finishing mechanics, okay? Number 17 says, of the specification says, be able to use the equation for work. Work is including calculations when the force is not along the line of motion. Okay. Work. What is work? Work is defined as the force, work done is defined as the force causing a motion multiplied by the distance traveled in the direction of the motion, okay? So work, which is by the letter W, is the force times the distance. If you have an object, a box, let's just draw that better. If you have a box that is on the ground and a person is pushing that box, hands are too long, but it's okay, and they exert a force on the box along here with a force of 10 newtons. That box moves a distance from point A to point B. This distance is 5 meters. The work done by the man will be 10 times the direction in which the box is moving, the distance along which the direction of the force is, okay? Which is this distance. So times 5, you'll get 50 Newton meter. Newton meter is the SI unit, okay, of work done. At times, you will be given different scenarios. So this is for work when force is in the same direction as the distance the object moves, okay? In another scenario of work, distance may be in one direction while the force may be in a different direction. How do we solve this? Let's take up another example, okay? You have the same box, and let me just draw that better. The box is along the floor again. Yeah? However, this time, you are using a different machine to pull. Let's say you're using a crane. This is a heavy box, okay? And you're using a crane to pull the box. So you're pulling, the crane is attached to the box over here, and you are pulling the box in this direction, okay? How do we solve this? Let's just draw that in a more simpler way. This is the box. This is the direction at which the force is pushing the box. And the box moves a distance from here till here. So the box moves this distance, okay? How do we solve this? In order to solve this, to find the work done, we must resolve the force, because work done is the force that causes motion multiplied by the direction at which the box moves. So if the box moves in this direction, the force must also be in this direction. So questions will give you an angle. They'll give you this angle here, theta, and they'll tell you the force will be F and distance will be D, okay, D1 and F1. So what is your work done? Work done is equal to force times distance, but force is not resolved. How do we resolve force? We just use trigonometry. This is theta. This is your right angle triangle. We're trying to find the force. So force is the adjacent. F1 is the hypotenuse. So we can use cos theta is equals to the adjacent, which is force, over F1. So force will be F1 cos theta. So your work done will be F1 cos theta times D1. Let's take an example. You have a box that is being pulled at a force of 15 newtons. The angle at which it is being pulled is 25 degrees to the horizontal, and the box moves a distance of from A to B. That distance is um, 25 meters, okay? What is the work? So work is force times distance. However, we have not resolved the force. We can just draw the triangle here. This is this is 25 degrees. This is 15. Your adjacent, which is F, will be, you'll use the same relationship, cos theta. Cos theta is equal to adjacent force over hypotenuse 15. So F is 15 cos 25 degrees. This should be 25, okay? So your work will be 15 cos 25 times 25. That gives you, if you plug it into the calculator, you will get 309.9 watts, okay? I made a small mistake here. The SI unit of work done is not Newton per meter. I mixed it up with the before topic. Newton meter is the SI unit of moment, which is the previous topic to work. The unit for work is is joules. Okay, work is it's a form of energy, work done. So it should be in joules. Okay, I don't know why I keep writing watts. Work is represented with W, so I keep writing watts. But yeah, apologies for that. We can just take this off. Be able to use the equation of kinetic energy of a body. Kinetic energy of a body. How do we define kinetic energy? So Ke, which is kinetic energy, is the energy an object possesses due to its motion. There is a formula for this. Kinetic energy is a half times mass times velocity square. M is the mass and v is the velocity. So that's your equation for that. So we can just take that off. Be able to use the change in gravitational energy is equal to mg change in h for the difference in GPE near the Earth's surface. That's kinetic energy. What is GPE, gravitational potential energy? GPE is the energy an object possesses due to its position in a gravitational field. Okay, when an object, this is the Earth, we do know that the magnetic fields run in this direction. So from the South Pole to the North Pole, and it basically runs through, same way on this side. And as we keep on going, it becomes further away, okay? So, say you have this is the ground of the Earth. You have an object over here, and you have an object over here. Which one will have greater gravitational potential energy? GPE in O levels, as we know the formula, is mass times the gravitational field strength and times the h, okay? Mass is, m is your mass, g is 9.81, and h is the height, okay? I misspelled that. Height, okay? There is a type of question that they can ask you here, okay? A ball has been thrown up and it travels with a velocity v. When it reaches up the peak, the ball stops. So the projectile motion of the ball is as follows, but we'll only use this portion of the ball. The ball is thrown over here, and at here its velocity is equal to 0. Okay? They may ask you, what's the distance the ball moves? Or they might ask you what's the initial velocity of the ball. Um, this this can only be used if the ball is thrown from a distance of 0 meters per meters from the ground. So how we will solve this will be the loss in kinetic energy is equals to the gain in GPE. Reverse scenario is if the ball has been dropping down and reaches the ground, okay? For that, we'll use the opposite. We'll use gain in KE is equals to loss in GPE. How do we solve this? What equation do we use? Half m delta v squared is equals to a half times, sorry, not half, but mass times g times change in height. Mass is constant, we can just cancel that out. And yeah, so this, you can plug in your values here and solve for whatever quantity you may need. That's what GPE is. Know and understand how to apply the principle of conservation of energy, including use of work done, GPA, and kinetic energy. Okay, principle of conservation of energy states that, so the principle of conservation of energy, we can just write it in short form. It states that energy can't be created nor formed, created nor destroyed, but it is transferred from one body to another body. Okay, so what do we mean by this? The energy a object possesses cannot be destroyed. However, it can be lost. What do you mean by this? When we have a ball and the ball is dropped onto the ground, it doesn't lose its energy. It just transfers it to its surroundings in the form of heat, sound, and other forms. Okay. So the principle of conservation of energy can be represented in a formula. Total energy in the system is equals to the total energy out of the system. Okay, we can just take that. Be able to use the equations on power. Okay, power is equal to energy over time. So what is power? Power, which is which has the symbol P, is the rate of transfer of energy. So rate of transfer of energy. Power can be represented by the formula energy over time, and the quantity for power is, the SI unit is watts. This is the SI unit for power. Okay. There are multiple equations that can be used for power, like energy is equal to VIT. This is electricity. So when you plug it into the equation, you get power is equals to VIT on T. T cancels, and you're left with VI. However, this will be in next topics, not now. You will need it for mechanics. So for now, power is equals to energy over time is the only formula for power that should be known. Okay. That can be ticked. Be able to use the equations for efficiency. Okay. So efficiency is how effective a system is. You may have seen this diagram before. It is my diagrams are very bad today. It's an arrow, and this arrow has a side arrow. So this is the input, and these two arrows show the output. One is the useful output, and the other one is the not useful output, so it's the lost output. Lost output plus useful output will give you the input power, okay? So how what formula can we use? Efficiency has many formulas. Let's just say the useful output, and then we'll put a dash here over the total input dash times 100. What is in this dashes? In this dashes, you can have useful power, you can have useful energy, and you can have other forms, whatever other forms that they may give you. You can use it to find your efficiency. That's it for IAS Edexcel Unit 1 Mechanics. I do understand that we skipped 16, but we didn't. It was in the previous video towards the end. We talked about equilibrium and the principle of moments. So that is there. For the next video, we'll be looking at materials. And that materials is a bit short, so we'll finish this in 2 lessons, 2 videos, and then we'll move on to Unit 2.